Alright, geometry class, this is Mr. Kim again. On this video, we're going to take the coordinate proof of the mid-segment theorem and apply the coordinate proof to prove that MN is equal to 1/2 AC, or the mid-segment is equal to 1/2 the length of the third side, or the side that it's parallel to. Okay. So again, we're going to use the coordinates AH, BK, and CL. Now, to show that MN, the mid-segment, is 1/2 the length of AC, we need to use distance, or the distance formula, right? Because we're on a coordinate plane, or we're using coordinates. So just a reminder, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. It really doesn't matter whether you use x2 or x1 first. Just subtract your x's, find the difference between them, and then square them. And then take your y's, find the difference between them, and square them. This is where the Pythagorean theorem comes from. Alright, so let's find the distance of AC first. I'll do that right underneath here. So AC is going to be equal to, take the x coordinates, A and C, subtract them. So, or actually, doesn't matter. Yeah, let's just go C minus A. C minus A over here. C minus A squared plus, now same order, L minus H right over here. So L minus H, oops, that doesn't look like an H, squared. Now we're not going to multiply this out and expand this out because these are binomials, C minus A times C minus, we're not going to do that because the point is we just need to prove that this length is double MN. And to do that, we just need something that's similar to this. So here's what I mean. Next, we're going to move over to MM and using the same idea. We're going to take the coordinates that we had before for MN, meaning in the previous problem where we found the midpoint of the coordinates of M and the coordinates of N. I'm just going to write them down real quick. Oops, that's not what I want. So let me write them down. We've got B plus C over 2 and K plus L over 2. So that would be the coordinates of N. And the coordinates of M are A plus B over 2 and H plus K over 2. Alright, so what we're going to do is just focus on these two coordinates for M and N. And we're going to use the distance formula. We're going to subtract, just like we did down here. We're going to do C minus A, L minus K. Or sorry, L minus H, and do the same thing. Y minus Y, and then x minus the x. Okay, so let me rewrite this. So that's y2, x2, y1. That doesn't look like a y. y1, x1. And when we substitute them into our formula up here for the distance, it'll make more sense. So give ourselves some room. Distance equals. All right. So x2 minus x1. That's b plus c. Right, b plus c over 2 minus a plus b over 2. And remember, I'm going to put the parentheses around here just to show that we do need to distribute the negative right there into a and b. Let's put a giant squared symbol around this using brackets. Now the same thing for my y's. Okay, so let's take the y coordinates of k plus l over 2. Minus h plus k over 2. Again, parentheses around here, and we are going to square the sum, or square the difference, sorry. So here we go. Simplify. Long steps. I'm going to show every step, so be patient, please. We still have b plus c minus a minus b all over 2. That's going to be squared. And then we still have k plus l minus h minus k all over 2 squared. And if you didn't watch my first video, I explained why I'm able to take this expression here and simplify it and leave it as a big numerator all over 2. And the simple answer is that they both have a denominator of 2, so I can basically write the numerators as one line. That makes it easier to see the distributive property happening with the negative here. Anyway, let's continue to simplify. D equals C minus A over 2 squared, because the B and the B negative B here cancel out, plus L minus H all over 2 squared. Okay, and so far you can kind of tell we're almost there. Over here on the right we've got C minus A over 2, L minus H over 2. Here there's no 2 in the denominators, so the question is how do we get them out? Well, we have to simplify a bit more. This is a bit weird at first, but it makes a lot of sense. What I'm going to do is I'm going to separate the numerator and denominator by actually squaring the denominator. What that means is I'm going to keep C minus A quantity squared, but I'm going to apply the square to the 2. Because technically I'm not doing anything wrong because I still have to square the numerator, I just haven't squared it yet. The numerator and denominator are separate in terms of squaring because numerator multiplies to numerator, denominator multiplies to denominator, which is why I can get the 4 here and still keep C minus A squared. Same thing over here on the right side, L minus H squared all over 4. Why am I doing this? Because I want to take the square root of these 4's and take them out, right? Because these are perfect squares, right? Really, these are 1/4 over here in black, maybe. Right? That 4 really is a 1/4, right? Put a 1 in the front there, right? It's a 1/4. So I can square root of 1/4 and get a 1/2, and that's the idea. So why did I say 1/2? Because in the formula over here, we need to prove that Mn is 1/2 of AC. So that's the goal. So let's go ahead and take the square, wrong color. Let's take the square root of the 1/4, which is going to be 1/2, right? So maybe I'll do this to show you a bit better where this is going. So this is really 1/4 times C minus A squared plus 1/4 times L minus H squared. Okay, that's where it comes from. We're basically getting ready to distribute out, or backwards distributive property, or factor. So once we take the square root of 1/4 and 1/4, we get 1/2, right? Goes on the outside. And we still keep our square root sign with our C minus A squared plus L minus H squared. So we're almost done now. So we've proven that the distance of all of this is for Mn. Everything we've done here on the right side is for Mn. Everything over here is for AC. So let me just replace this distance here as Mn. So Mn equals 1/2 square root of C minus A squared plus L minus H quantity squared. What I can do is just substitute AC, because AC is already equal to all of this, and simply substitute AC for the square root part over here. So Mn equals 1/2 AC, and we've just proven that the mid-segment Mn is 1/2 the length, or 1/2 the distance of the third side AC. Alright, good luck with that. That finishes up the classwork. Make sure you understand the content and the concept when you do the homework. Good luck.